Hi guys, welcome to the Get East Tech YouTube channel. This is the second additional circuit example video. The name of the video is RC charging circuits. If you haven't watched the other videos yet, I would recommend you to watch them first. I'm saying this because we have used RC circuits in the transient analysis circuits, and today we will give some details about this RC charging circuits. Okay, let's get started. I've already opened the software program, and I think everyone is familiar to these fundamentals after 10 videos, and I'm not telling how to open and how to build the circuits. Okay, our circuit is ready, but we will do a new thing for today, and today we will give a start condition, initial condition for our capacitor. To give a start condition to your capacitor, by clicking twice, there is a property editor page is opening now, and this is a property page, property editor, and we will arrange the initial condition value here in this blank. You see it. Okay, come to the IC blank and click right from your mouse and click display button. Okay, display property is opening now, and you have to display format. You have to select the name and value for the display format, and it should be selected. Okay, and now click OK. You can close it now, and you see there is an IC blank, and our start condition, our initial condition is going to be 1 volt. I think, okay, we are ready to create a simulation. Okay, click pspice and new simulation profile, give it the RC charging. Okay, create it. Okay, it's gonna be a time, it's gonna be time domain transient analysis in this video. Time domain transient, and run to time is going to be 0.1 second for this project, and maximum step size is 0.001 seconds. Apply and okay. Okay, now everything is everything looks good. I think there is no problem. Okay, we are ready to run our simulation. By clicking F11 you can run your simulation. Okay, let's see our graphs. There will be two different windows in this project. I'm using two of them. Add plot to window from the plot. Add plot to window from this place. Okay. In the upper window, I will show the capacitor voltage, and to show a capacitor voltage, I will add a trace. Come to add trace button and show your V capacitor. Okay. And now in the bottom side, I'm gonna show the current through capacitor at trace and IC1. Our capacitor name is C1, and I'm trying to show the capacitor through a current through capacitor, and click OK. Okay, actually it should be reversed. Um, we have to change something in our simulation. Okay, there is a problem. We have to rotate our capacitor twice because plus and negative sides are interchanged. We have to change it because this is initial condition is 1 volt, but in the graph it was minus 1 volt, and we changed it, and now everything is okay. Let's run our simulation again. Sorry about that. Okay, simulation is coming. Okay, add a plot, add a new window. In the upside, I'm going to show a voltage through capacitor, and in the bottom side, I'm going to show current through capacitor. Okay, you see the graphs are here in this circuit. This is our graphs. Okay, I need to give some technical informations to analyze these simulation graphs. Before we get started, I will say that what is time constant? And time constants represent the time response of the circuits when an input step voltage or signal is applied. The resultant time constant of any electronic circuit or system will mainly depend upon the reactive components, either capacitive or inductive. The unit of time constant is tau. It is also shown as tau. And the electrical charge stored on the plates of the capacitor is given as Q is equals to capacitor value times voltage value, and the transient response time T is also T is equals to R times C in seconds, and the time required for the capacitor to be fully charged is equivalent to about 5 time constants. Here in the circuits, our time constant is T is equals to R cross C, and let's look at what is the R value. R value is 10, and capacitor value is 1 microfarad, and I understand that our time constant is 10 milliseconds, and fuel discharge time is it should be 50 milliseconds according to our time constants, because our time constant is 10 milliseconds. And let's look at the circuits. So let's look at the graph. As you see, in the 50 seconds, the capacitor is fully discharged. Also, the capacitor is charged in 50 seconds. After that, everything is like DC current graph. This is, I think everyone understands the main idea. Time constant is really important for capacitor and for charging circuits. And let's give some example. And this is a configuration of capacitor charging voltage and capacitor charging currents. As you see, in the time constant 5t, capacitor fully charged, and this is a formula, something like that. Also, there is a table. In the 5 time constants, the capacitor is charging approximately 100%, but when we make the time constant is less than 5t, it is charging less. You see 98% and 95, 86, 63, and something like that. And this table is also important. I will add to the links of this those images in the description box. Okay, that's enough for today. I think everyone understands the RC charging circuits. Thank you very much for this video, and see you in the next tutorial.